Okay, so today we are going to look at IPv6. During the classes that we have had during this semester and also your lab, you would have seen and you have tried IPv6. When we talked about static route, we talked about how to configure that with IPv6. You know, when we talked about dynamic routes, we talked about how to configure that with IPv6 as well. But that was just us using the IPv6. So in this class, we are going to look at IPv6. So firstly, why do we need IPv6? One is because of the exhaustion of IPv4. We don't have enough addresses to pass around anymore with IPv4. Many elements or methods have been tried to help ease this problem. That includes VLSM, that includes the use of private IP addresses, that also include network address translation. But still, we are at the area where we are having a problem. So we need IPv6. Another reason for why we need IPv6 is because the Internet of everything, the Internet of things, where you have all of this different sensors and machines and that helps you out. And all of these, they need their own IP address. And because of that, IPv4 is not enough anymore. Another reason why we need IPv6 is because of the opportunity that IPv6 gives. For example, in IPv4, there are certain elements in it that are not so very good, right? So this is the time when we restructure everything and come up with a better, with a more correct and enhanced version of IP addressing. There were issues in IPv4 that we can address with IPv6. There are things in IPv4 that are not suitable. We can take it out. So this is an opportunity to come up with a better way of addressing devices and hosts and the network. That's the reason why we have this. So if you look at here, most of the dates have been passed. This is the projected IPv4 exhaustion date. They have been passed. That's why you see many organizations, they rely on private addressing. One address that is doing within, using within their organization, and then on NAT to translate that into public address to go into the internet. So in the world, I think there's about 20-25% that has been using IPv6, but most people are still using IPv4 because it works. Why change? Because there will be a lot of changes. So there is no sudden turnover date. Sudden turnover date basically means, okay, by June of 2021, everybody must change to IPv6 because IPv4 will not work anymore. There's no such thing. Okay, so there is a migration, a slow migration to IPv6. And to help with this migration, because in the internet, there will be organizations using IPv4, organizations using IPv6. How can they communicate with you? So there are many migration techniques, and these migration techniques can be divided into 3 categories. One is dual stack, another one is tunneling, and the other one is translation. In dual stack, it allows both IPv4 and IPv6 to coexist on the same network segment. Dual stack devices run both IPv4 and IPv6 protocol stacks simultaneously. So of course, dual stack devices means new devices, right? So some organizations do not want to spend the money on that, but this is a way to go. Dual stack, you have devices that can run both IPv4 and IPv6 simultaneously. Another method is called tunneling. Now, in tunneling, you transport IPv6 packet over IPv4 network. It's sort of like IPv6 is piggybacking with IPv4. So the IPv6 packet is encapsulated inside an IPv4 packet. So before this, we looked at how a data, we encapsulate with the transport layer and then network layer and so on, and the data is encapsulated. But here, what happens here is that the IP version 6 packet with all its data and everything inside, that packet is encapsulated into IP version 4. And that is what you call tunneling. Sort of like it is using the IP version 4 as a tunnel. Another way is to use translation, very similar to network address translation that we have learned in network communication. You have a private address, and then it is translated into a public address, so you don't need a lot of public addresses. But here, the network address translation 64 or NAT 64 allows IP version 6 enabled devices to communicate with IP version 4 enabled devices using a translation technique similar to NAT for IP version 4. Okay, so it's sort of like I'm talking in IP version 6, but if I want to send it to the device that's talking in IP version 4, I will translate that into IP version 4 so that they can actually handle. So an IP version 6 packet is translated to an IP version 4 packet and vice versa. So these are the three ways that IP version 4 and IP version 6 are coexisting in the world internet. So let's look at IP version 6. In IP version 4, we have 32 bits. That 32 bits is represented in 4 octets, where octet means every portion is 8 bits. In IP version 6, the addresses are 120 bits long. And because it's 128 bits, and because 128 bits is a lot to write, they have written it, excuse me, they have written it in a form of a hexadecimal string. If you see here, this is actually 1, 2, 3, 4 hexadecimal, whereby that 4 is actually 16 bits in binary. Okay, so they're sort of like compress that into hexadecimal, so it would be not as long to write, but it is still quite long. So every 4 bits is represented by a single hexadecimal digit for a total of 32 hexadecimal values. So these are the preferred format of IP version 6 addresses. So if we have been using 192.168.22.4, even that sometimes you feel like, what is the IP address for one? So IP version 6, there you go. So the question is, this is too long. Can we reduce the notation of IP version 6 addresses? The answer is yes, but there are some rules that we need to follow. Let's look at the rules. The first rule is to omit leading zeros. Leading zeros means the zeros in front. If we're talking about decimal value, 0, 1 and 1, 0 is not the same. 0, 1 is 1, 1, 0 is 10 in decimal, right? So the leading 0 in 0, 1 doesn't mean anything. If you throw it out, it's still 1. So the first rule to help reduce the notation of IP version 6 addresses is to omit any leading zeros in any 16-bit section or hexdec. In IP version 4, you call it octet. In IP version 6, we call it hexdec because you are using 16 bits of hex. So this is some example. 01AB can be represented as 1AB. So the front 0, you can take it out. Like here, 00AB, you can just represent as AB. So there's less to write or less to type. So this rules only applies to leading zeros, not trailing zeros. Okay, remember, 0, 1, 1, 0 are different. 0, 1 is 1 in decimal, 1, 0 is 10 in decimal. If you take out the 0 in 10, it becomes 1, which is like a totally wrong. So if we look at the preferred address down here, okay, we can take all the leading zeros in every hexdec and take it out. So we have a shorter version. Well, short a little bit lah, but it is still quite long. So another thing we can do is to omit all 0 segments. There are certain segments like this one. For example, here, the segment here is all zeros. These 3 segments here are all zeros. So we can actually omit them. So what we do is we add a double colon, and this double colon will replace any single contiguous string of one or more 16-bit segments or hexsets consisting of all zeros. Now, one thing to do or one thing to remember here is this. You can only use it once. So in this example, you have a zeros hexstet here, all zeros hexstet here, and then you have 3 at the back. You either choose to use it in front or at the back. You cannot use both. In this example here, what it did was that it took the 3 at the back and replaced it with that. See that double colon over there? So now this long address has been shortened by the double colon. So if you look at this one, this is incorrect. Why is this address incorrect? When you see 2 colon, okay, 2 double colons here, that is wrong. You only have 1. So very, very important to remember. So let's look at a few examples. This is the preferred address, which is the standard long one. And then if we take out the leading zeros, we will get that. If we compress it, meaning any hexsets that are contiguous and all zeros, we put a double semicolon. So in this case, this one, they still use it, but this one they take this one out and then use the double colon. Or you want to stay this one, it's still the same, and then you use the double colon at the back. Either one, okay? And then you have shortened the address. So another example, this is a link local address, and then that also can be shortened with the double colon. If everything is 0, if 0, 0, 0, 0, and 1, you can do it this way. And if you remember, when we were doing the static route for IPv6, it was very easy because it's just :/64. Go. So in IPv6, there are different address types, very much like IPv4. In IPv4, we have unicast, multicast, broadcast, right? So in IPv6, we have unicast, multicast, anycast. It doesn't have any broadcast. So what is unicast? Unicast is a uniquely identified address of an interface on an IPv6 enabled device. Unicast, unique address. Okay? Multicast, an IPv6 multicast address is used to send a single IPv6 packet to multiple destinations. It's sort of like a group. So there's multicast in IPv4 as well. Now, anycast is an IPv6 address where any IPv6 unicast address that can be assigned to multiple devices. So a packet sent to an anycast address is routed to the nearest device having that address. Now, this is just for knowledge because anycast addresses are beyond the scope of this course. We will focus on unicast and multicast. Now, think about this for a second. How does broadcast being done in IPv4, sorry, IPv6? So while it doesn't have broadcast, IPv6 all nodes multicast address can give you the same result as a broadcast. They don't call it broadcast, they still call it multicast, but you can use a multicast everyone and then it will send to everyone. Okay? So unicast, multicast, anycast. Now in an IPv4 IP address, you have a subnet mask. Right? In IPv6, you have what you call a prefix length. So IPv6 uses the prefix length to represent the prefix portion of the address. It does not use dotted decimal subnet mask notation. So the prefix length is used to indicate the network portion of an IPv6 address. So it will be addressed something like the IPv6 address, and then you have / prefix length. Okay? So it will show you the network portion. In essence, it is kind of like the subnet mask, but that is where the similarities end. Okay? So the prefix length can range from 0 to 128, but the typical IPv6 prefix length for LANs and most other types of network is /64. So this means that the prefix and network portion of the address is 64 bits, and the other 64 bits is the interface ID, which is the host portion. So the prefix tells you the network portion, and then the remaining however bits is the host portion. Now, one thing interesting with IPv6 is the host portion is untouchable. If you remember, when we were doing IPv4 addressing, subnetting, when we did the subnet mask and we set aside the network portion, and I said network portion cannot be touched. If you want to subnet, you have to use the host portion. In IPv6, the host portion is untouchable. You cannot change it, add it, well, you cannot do anything to it. The 64 bits remain. Okay, so how do we do subnetting in IPv6? We take from the network portion. Okay, we'll look at it in a little bit. So again, we have the prefix, tells you the network portion, and then the remaining bits is the interface ID or the host. If we have an example like this, it's 2001 DB8 A, and you have a double colon here. That means after A, every hex stat is 0. Okay, after A, every hex stat is 0. So 1, 2, 3, 4, and after A, every hex stat is. So far, so good? Okay. So let's look at IPv6 unicast addresses. Okay. So as you know, unicast address uniquely identifies the interface of an IPv6 enabled device. So there are many types of IPv6 unicast address. There's a lot. But the most used or the most popularly used is global unicast address or GUA and link local unicast address. You have the loopback, you have the unique local, you have embedded, But these are the two that you will see the most. So global unicast address is similar to the public IPv4 address. By that, it means it is globally unique. It is routable. That means you can put it inside IP routing and then it is routable in the internet. It can be configured statically or assigned dynamically. That is global unicast address. So if you see here, this IP address here, this is its global unicast address. This is this network's network address. And this is their GUA for each of the devices. Okay. And if it wants to send something within the subnet, they can just send it. Similar network. Link local addresses are used to communicate with other devices on the same local link. You can think about the local link like it is a subnet. So this is address that they use within the subnet. Okay, they don't use the GUA. The GUA is used when you want to talk to somebody who is outside of your subnet. So if somebody is inside the subnet, they use link local. Now, link local addresses are confined to a single link, not routable beyond the link. So if you see here, the link local addresses, which is FE80, okay, mostly it is FE80 here, and it only works within the subnet. It cannot go out. To go out, to go to the other network, you have to use the GUA, the global unicast address. So the IPv6 link local addresses are in the FE80 /10 range. So this /10 means the first bits you cannot change. It will be 1111, 111010. That one you cannot change. The other bits at the back, you can change them. Okay, the other bits at the back. So the first hex stat has a range of 1111, 1110, 10, and then all of this is 00000, which is FE80 until FEV. So that's the range of the link local. Unique local addresses are used for local addressing within a site or between a limited number of sites. It should not be routable in the global IPv6 and should not be translated to a global IPv6. So unique local addresses are in the range of FC00 to FF. As a security precaution, unique local addresses can be used for devices that will never need or have access from another network. That means if you are using it just for your small network, you can use the unique local address. But if you are going to outside of your local network, you cannot use that because this address will not and should not be translated to the GUI. You can look at unique local as a private address, but private address you can translate it to a public address, but unique local is not how should I say this? It's not advised to do so. You shouldn't do that. In IPv4, some people, some organizations, they use the private addresses as part of a security. That's not the reason private addresses were made. Although, yeah, you can use it, but that's not the reason it was made. You should have other form of security. But if you want to use it, you can. So let's go into understanding more about the GOA and the link local address. Global unicast address, the link local address. So let's look at GUA. So a GUA has three parts: the global routing prefix, the subnet ID, and the interface ID. Currently, only global unicast address with the first 3 bits of 001 or 200/3. This 3 bits has been assigned. Not everything else, only just these 3 bits. Okay, and note that the address 2001 ODB8 here, here, here.
Hello.
What's your question? Hello. Do you have a question?
Hello. Can you hear me? Yes, miss.
Come again?
Miss, but like, there is like for me also yeah.
I'm sorry, you are breaking up. Can you repeat that again?
The host portion.
The host portion,
So that means like for the first host portion, the go like the host portion is the global unicast address, is it? Is it
Are you saying?
Hello? Yeah, miss.
Hold on. In the middle of your question, it broke. Your voice broke. So repeat again. Let me try this. If I'm wrong, you let me know. Okay. Are you asking me which is the host portion?
Yes.
The host portion is the last 64 bits. This interface ID here, that's the host portion. This first 3 bits is what has been assigned to organizations. So if you see, because this is a long, text step, right? So only this 3 bit, 001. So what has been assigned is from 2000 to 3FFF, which has been new. And within that, this address, 2001 ODB8 :/32 address has been reserved for documentation purposes, including use in examples. So why they set that aside so that nobody will inadvertently or mistakenly use this address in the instance.
But even in IPv6, there be some wastage of subnet
Yes,
addresses, it means.
there is a lot of wastage, but they don't care because there is a lot of IP address.
But then how do we reduce or minimize it? It's always the same.
They don't.
Oh.
Because in a subnet, you can have 65,000 and then that is only one. I'll show you subnetting in a little bit and then you will understand. Okay. For now, let me introduce you what the address looks like so that when we talk about subnetting, you have a better understanding. Okay?
Okay, Miss.
Okay.
Thank you, Miss.
So, no problem. So coming back to this. So here, what it's trying to say that in this, look at this, how many, this hexstat if you want, this hexstat if you want. This is only the 3 bits has been assigned. Okay. So this one is made out of the GUA is made out of the global routing prefix, subnet ID, interface ID. So typically, the Regional Internet Registry, or the RIR, assign a /48 global routing prefix to customers. Whether it is companies or individual household, they will assign the /48 global routing prefix. The /48 prefix are the most common global routing prefix assigned and will be used in most examples throughout this course. So if you look at this, 2001 ODB8 ACAD /48, so the first 48 bits, which is 3 hexstats, 1, 2, 3 hexstats, is the prefix or the network portion of the address. The double colon, as you know, means that everything after that is all zeros. So they have compressed it. So if you see here, the 48 bits, this 48 bits here, 2001, ODB8, ACAD, this is the global routing prefix. Now, we saw that the part here would be like 64 bits, network portion would be 64 bits. So the 16 bits here, that would be the subnet ID. And the 16 bits here, that is used for subnet. Okay, this is what is used for subnet. This 64 bits interface ID or the host portion is not touched for subnet. It is assigned, but it is not like borrowed or whatever, it doesn't do anything. Okay, so the 64 bits network portion, the RIR will give you 48 bits, and then you can use this from all zeros to all ones. Subnet ID is used to identify subnets within its sites. The larger the subnet ID, the more subnets available. Meaning, if you have more than 16 bits, there is a lot of subnet you can. Okay, and also something to note is, unlike IPv4, IPv6, all zeros address and all ones address can be assigned to a device. In IPv4, all zero is network address, all ones is broadcast address. You cannot assign that to a device, to a host. But in IPv6, all is a go. You can use everything. Interface ID is the host portion of the address. And you might be asking why I call it interface ID, because a single host may have multiple interfaces and each having one or more IPv6 addresses. So it is highly recommended that in most cases, /64 subnet should be used. Basically, when you're assigning a subnet, every subnet is /64. That means all of this is the subnet. Okay. So here you have the same thing explanation, only in a more graphical way. So this is the address that you have. This is the compressed address. Everything is zero, and then the interface ID. Okay, and then preferred address, because this is compressed. This is the preferred. This one is actually this in real life, the very long one. But they have taken out the leading zeros and then they have compressed all the zeros at the back, so you have something like this. So this one would be, the green one is the global routing prefix. The purple one is the subnet ID. And then the interface ID is this one at the back. Now, this is an IP address for one device. Because his IP address, I'm just going to talk about the N here, which is 2, okay? This is 2. So their subnet is 1. So in subnet 1, I'm calling this subnet 1 based on this. Okay? So in this subnet, the IP address can fit from 0000000 until FFFFFFFFF. So you can have about 65,000 roughly of hosts within one subnet. Does not finish as, then there will be a lot of wastages. Yes, it will be. Because I don't think there is a host where you have 65,000, sorry, there is a subnet where you have 65,000 hosts. But because the number is so big in IPv6, they do not worry that it will go, it will not be enough. So how do you configure? Now, IPv6 addresses can be configured statically, where you assign each interface with an IP address, each device with an IP address, or you can assign it dynamically. So this is an example of assigning IP address with static configuration. So interface in R1 here, interface gigabit Ethernet 00, this address over here is given the IPv6 address 2001, DP8, a cat 1 in this first subnet, and his IP address is okay. In G001, C is in the second subnet, and this IP address is. And then this side, the serial, is in the third subnet, and that IP address is. And all of them have the prefix of 64. So here, even though there will be like 2 IP addresses used, they still get 65,000. Okay, and this is where you can assign to a host. Very much similar to how you assign an IPv4 address. Prefix length instead of subnet mask default. So how does a host get a dynamic IP address? So there are 2 ways in which a device can obtain an IPv6 global unicast address automatically. They either use SLAAC or they use DHCP version 6. Now, in stateless address auto configuration or SLAAC, and stateful DHCP version 6. So one is stateless, one is stateful. So when DHCP version 6 of SLAAC is used, the local router's link local address will automatically be specified as the default gateway address. Now, not the router's GUA address, the router's link local address. So when this host is attached to this network, it will send a router solicitation. It will send it to all IPv6 routers that it is connected to, which is this one. I need an addressing information from the router. So the router will send its router advertisement, very much like DHCP version 4, right? You want an address, the DHCP server sends it, but here the router sends you. And there are 3 options, but the first option here is SLAAC only. So if you're running SLAAC, what the router will send you or send the host is, this is your prefix, this is your prefix length, / whatever, and also your default gateway information, which is my link local address, the router's link local. Now you might be thinking, why is the router giving a link local address and not the global address? Because this PC, to connect to this, they are in the same subnet. He doesn't need to know the GUA. He needs to know the link local. Okay, that will attach him to the same subnet as the router, and then everything else will work. So router advertisement options, there are 3. There is option 1, which is SLAAC only. In SLAAC only, the router will give you every information you need. Your prefix length, your default gateway, everything. In option 2, it is SLAAC and DHCP version 6, where the router will give you your prefix and prefix ID, but for you to get your DNS and every other information, you have to go and ask from the DHCP version 6 server. And option 3 is DHCP version 6 only, where the router doesn't join in, only gives its link local address, but all the other information you have to get from the DHCP version 6. So how do you set these options? These are set by the network. Okay, but one thing you have to understand is this. If it is running SLAAC, all information needed will be given by the router in its router advertisement. If it is running SLAAC and DHCP, which is option 2, the router will give its information like link local prefix, but DNS and everything else you have to get from DHCP server. Okay, and if it is DHCP version 6 only, you have to get every information from the DHCP server. That is SLAAC. So basically SLAAC, how it works is that the PC comes into the network and then it will solicit You say, I need, and see, no one is tracking, I need an address. I need an address. So the router will send the router advertisement. And remember, this is option 1, which is flag. So in this, he has his prefix length is given. And also the link local address of this particular IP address, particular router interface. So when the PC or the host gets the prefix and the prefix length, it has to create its own ID. What? Yes, it creates its own. How does it create its own IP address on the interface side? This part is set. This part is set. But this part, he will create either using EUI64 or a randomly 64-bit number generator. So the host will actually create this part on its own. I will show you the EUI64 in a little. So with Slack, the client device uses the information in the router advertisement message to create its own global unicast address. Cool, huh? So in the router advertisement message, what is in there? There is the network prefix and prefix length. Okay, so if you see here, this is the network.
So the IPv6 address is automatically created. You don't need to create one.
Come again?
So the IPv6 address is automatically created.
The interface part. The interface ID part is automatically created. The prefix part, the network portion, is given, is assigned, which is assigned here, the network prefix and the prefix length. This is given. Only the interface ID part is created by the host device. Okay, be very careful about that. The IP address is not created automatically. The interface ID part of the IP address is created because this part is given by the router advertisement. So the router prefix and the prefix length, which is /64, this is given in the router advertisement. Default gateway, which is the link local address of the router, is given. Okay, so the source of IPv6 addresses in the RA messages. And the DNS addresses and domain name, address of DNS servers and domain name. Okay, these are what is in the router advertisement message in IPv6. So one thing to note is that IPv6 routing is not enabled by default. So to enable a router as an IPv6 router, you have to type IPv6 unicast routing global configuration command in the global configuration. So if you are using IPv4, you can straight away configure IP addresses, configure routing without worry because by default it is enabled. IPv6 routing is not enabled by default. So if you are going to use IPv6, you have to tell the router that you are going to use IPv6 with the command IPv6 unicast. Okay, it is sort of like a way, by default, our classes are all in English, right? But if you want to talk to me in, let's say, Bahasa Malaysia, then you say, can I speak in Malay? So that's you are changing the default to Malay. If you want to speak to me in Spanish, then, can I speak in Spanish? So that is the instruction that is telling the router to change the way it manages things. Because before this, it is ready to manage things IPv4 style. Now it has to change and manage things with IPv6. So remember, by default, IPv6 is not enabled. You have to enable it with IPv6 unicast. So DHCP version 6. Just now we looked at dynamic configuration using Slack. Okay, how about DHCP version 6? So the PC goes in, it sends a router solicitation. The router, upon getting the router solicitation, will send a router advertisement. Okay, so here is your prefix length, the default gateway. But if you want DNS and other information, you have to go to the DHCP server. So once the host gets this, it sends a DHCP version 6 solicit to the DHCP version 6 server, and then the server will reply with the DNS address and all the other information. So that is DHCP version 6. So how does the device create its address? Okay. The client knows the prefix portion because it is given to him, but it must create its own interface ID. And this can be either using EUI64 or random 64-bit number. Random means random. You know, it's sort of like, oh, I got number 5. Oh, I got number 1444. Doesn't matter. It's random. But EUI64, now this is a process that where it uses a client's 48-bit Ethernet MAC address, uses the MAC address, and inserts another 16 bits to make it a 64-bit interface ID. How does it do that? If you remember from Netcom when we talked about MAC addresses are 48 bits. Okay, the first 24-bit is the OUI. Okay, organizationally unique identifier. It tells you the vendor. So all Cisco products would have the same 24 bits here. All Cisco products would have the same. This is the only thing that is different. So it takes the MAC address, divided into half, the 24 bits, 24 bits. You see, you do that, split it, divide it. And then in between here, they insert 16 bits. FFFE. See that? F, F, F. They put it in there. So just now it was 48 bits plus another 16. That makes it 64 bits. Now, after you insert FFFE, you flip the UL bit. So this is the UL bit. The UL bit is the 7th bit. So you count 1, 2, 3, 4, 5, 6, 7. Okay, that's it. So you flip it. If it's 0, it becomes 1. If it's 1, it becomes 0. So in this case, it is 0. You flip it, it becomes 1. And this is your new interface ID. FE9947 FF FE75CE E0. This is how the EUI64 process is done to give you an interface ID for the host IPv6 address. But there is a question here. The issue that some people put forward is this: if it is using my MAC address, everybody will know my MAC address. So where is the privacy in that? So, you know, when you do ipconfig, for example, this one run away a little bit, but follow the colors, okay? The green one is this part from the router advertisement message, which is the network prefix, then prefix length. And then this part is where you have the ID, interface ID, where you take the MAC address, split it into 2, add the FFFE, and then flip the 7th bit. So some people are not very happy with this because they feel like their privacy is being encroached into. You know, somebody's messing with their privacy. So rather than use EUI64, they chose to use randomly generated interface ID. So Windows Vista and up generates a random ID and do not use EUI64. So a random bit is just any random number lah. Any random number. So this one will follow, if you see, it's the same. 2001, DB8, AC81, 2001, DB8, AC81. The green part doesn't change because that is from the router advertisement, but this part, the orange part, is the randomly created. So for the interface ID, the host have to come up with its own, and it comes out either using the EUI64 or a random 64-bit number. So we looked at GUA just now. Now we are going to look at link local addresses. As you know, link local addresses are only active within the subnet. So all IPv6 devices must have an IPv6 link local address. Must have. Okay. A link local address can be established dynamically or configured manually as a static link local address. Mostly when you are using IPv6, you get a dynamic link local address. Okay, but you can actually configure a static one for it too. So a link local address, see this part just now, the FE8010, this part is fixed for that particular subnet. And then this part can, of course, change. And then here, this is randomly generated or using the UI64 process. So if you look here, ipconfig, this is the GUA, IPv6 address, this is the GUA. And this GUA is using EUI64 because you see the FFFE there. And then this is the link local address. Okay. Okay. So if you want to see the IP address, if you want to verify it in a router, you can actually look at this. You see, show IPv6 interface brief. Every interface, it will show you the link local address and also the GUA for that particular interface. And if you look here, find that there is FFFE, and this is using EUI60. How do you assign link local statically to an interface? You use the IPv6 address, link local address, link local. So this is an example. Okay, in the interface interface gigabit Ethernet 00, that IPv6 address, and then this is the address that you want to assign, and then they ask you whether you want it to be link local. Then you assign it IPv6 address, whatever the address you want to give it, and then type link local. And this will be the link local address for this interface in this router. You can actually assign it statically, manually assign it. Okay. So router link local addresses are used as default gateway in routing advertisement messages. So just now when we looked at Slack, when the host comes in and asks for, an ID, an IP address, the router sends the default gateway as its own link local address. So for link local addresses, the range is FE80, FEBF. This is the range. So everything here is FE80. The one thing you have to understand about IPv6 is that it is long and it has a lot of numbers. So you don't really have to think about much of subnet. So, excuse me, once you have assigned it, of course, you have to verify it. And when you verify it, it will come out. Now we're going to look at how you subnet IPv6. So, of course, IPv6 subnetting will require a different approach from IPv4. Why? Because one, it has a longer bit, for the address. Two, the interface ID, the host portion, you cannot touch it. You cannot touch it to subnet. So you have to take from the network portion. Okay. So due to the large number of IPv6 addresses, there is no longer the concern for conserving addresses. There are so many addresses. You don't have to worry anymore. The IPv6 address plan can focus on the best hierarchical approach to manage and assign IPv6 subnets. So IPv6 subnet is about building and addressing hierarchy. It's about building and addressing hierarchy based on the number of subnetworks needed. So there are two types of assignable IPv6 address. We just looked at that. There is the link local address. It is never subnetted because it exists only in the local link. And there is the GUA address or global unicast address that can be subnetted. Okay, link local cannot be subnetted. Only GUA can be subnetted. So the IPv6 global unicast address normally consists of a 48 global routing prefix, a 16-bit subnet ID, and then a 64-bit interface. Okay, so this, the 48 bits, is given to you by the RIR, the registry, the RIR, I forgot what it's named, right? And then this is what you can subnet. When this is given to you, this is given to you all zeros. Okay, and then this one, you create your own. So subnetting is very easy. You're given this address because this 3 hex text over here are given to you, the global prefix. This is all zeros until all one. All zeros, one subnet. 001, the second subnet. 002, the third subnet. Fourth subnet, fifth subnet, and so on. And then every subnet, it has 2 to the power of 64 bits, 2 to the power of 64 addresses. You have about 65,000 addresses for one subnet. Okay, so it's very easy. How do you subnet IPv6? Ta-da, done. Okay, so to determine the next available subnet, just count up in hexadecimal. 0, 1, 2, 3, 4, 5, 6. Of course, this is hexadecimal. After 9 is A, B, C, D, E, F. Okay. Okay. Very easy, right? Subnetting. That's it. Anyone amazed by this or don't understand this? Everybody okay? Okay, good. All right, good. So here, this is one subnet. Okay, since this subnet is 001, and then this is the interface ID. This is another subnet. This is another subnet. This is another subnet. And here, with only 2 interfaces in the whole subnet, you still get 65,000. Yes, it is wasteful, but it is not a concern in IPv6 because it is very, very large. So this is how you set an IP address, the GUA address for the base. And we're done. So today we looked at why do we need IPv6? How is IPv6 addresses looks like? How do you write it? How do you make it simpler? And then we looked at the different types of IPv6 addresses. You have the GUA, you have the link local, you have all the other stuff as well. But we are focusing on these 2. And then GUA, how do you get an IP address? You can manually set one, or you can actually dynamically assign an IP address to a host, whether using Slack or DHCP version 6. Where Slack, host comes into the network, asks the router, I need an IP address, solicits the router sends an advertisement, okay, fine, this is your global network, global, and this is your prefix length, and then this is my link local address, and your ID, you create your, so the host will create its own interface ID using either EUI64 or a randomly 64-bit generator. And you put the global prefix and the what should I say, the interface ID together, you get the IPv6 address for that particular host. In Slack and DHCP version 6 portion, the router will tell you its prefix length and prefix address, and then so his link local, and then it will ask you to the host, of course, to ask the host to contact the DHCP version 6 server for any other information like the DNS server or whatever else. Okay, and then we looked at link local address. So what's the difference between GUA and link local? GUA is assignable, it is routable, you can go to the internet with it, you can subnet it. Link local, it cannot be subnetted. It doesn't go out of your local network, local subnet. Okay? It only works within the subnet. Then we looked at subnetting of IPv6, which is totally simple. You just change the subnetting ID part increasingly, and then you get 65,000 plus hosts for each subnet. And in IPv6, they don't worry about using or wasting a lot of IP address because there is a lot of IP address. And that is the end. Do you have any questions?